Well, I think we are going to get started for the last session of the day. And so thank you everyone for sticking around to the end here. What I'm going to be talking about a bit today is how we need to start working towards getting open source being able to be used in safety and security-based systems. And up till now, there's no really good precedence. And so the question is there, we want to use the features, we want to use the functionality, but we also want to make sure it stays safe and it's secure. So the big question is, can open source be used with safety standards and security standards for that matter? I should probably adjust the slide. But the short answer is yes. However, there's a lot of major transformation necessary, a lot of forking, it's expensive, and the standards are complex and have been designed with a different mindset than is usual in the open source space. And there are many standards, a lot of which you have to spend a lot of money to get copies of, which is also antithetical to the open source ecosystem. There's a lot of standards out there. On the safety side in particular, 61508 is a reasonably good generic starting point, but there's a lot that can be derived from it. And there's a lot of different standards bodies out there to consult with as well. And in the end of the day, we want our software to be safe and secure. And so figuring out a pragmatic path to getting there is pretty much what this talk's working towards. One of the key things that's here is that the feature richness and complexity isn't enough. There is an adoption barrier. Unless we've got someone that is responsible for the software, and because people want to be like it or not, we have a liability ecosystem here, and especially when people's lives are at risk here. So no one wants to be first too. So we've got this interesting challenge for open source, and we also have to some degree a software development culture clash. Open source pretty much thrives on building on others' work, fail fast, agile development methodologies, and so forth. Software development for certification is more of a formal discipline. It has requirements for building things. It has formal verification, provability, and so forth. So you've got these two different sets of engineering tasks to be worked towards. And so, why we have this culture clash is not quite enough. It's difficult to map what open source development is using into terms that the V model and other methodologies are used by the certification authorities. Specification of features is key here. Comprehension, documentation. There's a lot of documentation, there's a lot of evidence that has to be pulled together and then formally proven out. Traceability from the requirements to the source code is key. And the number of committers and who's committing and how much is known, these all play a role in the certifications. And this is not all this information that's gathered as part of the open source ecosystem. The V model, which seems to be at the heart of, at least on the safety side, the traceability, is making sure that every code has a path and that we have the references between the requirements in the actual code, the verification of those requirements with tests, their satisfaction from the decomposed requirements, and then the implementation links from user stories. So there's a lot of documentation and argumentation that has to go in to actually go after these safety stories. And when you're putting features in and changing things, I think, what was it? I think the kernel changes 9 times an hour or something like that. There's an impedance mismatch between these two spaces. And so from the last year and talking with a lot of people and working with a couple of projects, the approach for certification on open source seems to be boiling down to understanding really how it's used in the system and limiting the scope to what's actually needed for that system. And then as much as we possibly can, automate so we can keep up with the pace of change and generate the documents from the testing and tracking system. And then also, as you're going forward with something formally, make sure you pull in your certification authorities early, sketch out the concept to them, make sure they're buying into it. These seem to be the steps that are probably going to be useful. We do have a lot of strengths, though, in terms of open source. Our code's available publicly. It can be scrutinized by anyone. The code reviews and direct feedback are all there. So the code quality is high. The challenge is making that discussion between what the open source community is doing and the certification authorities to make them convinced. And then also to convince people themselves that, yes, you've thought of the key bugs and they've been removed. And so, have you actually removed the key bugs is a function of who's reviewing your code. Who has the final say. And how do we guarantee that the reviewer is aware of safety implications? This is a domain that we don't have a lot of people in open source today, in an influential roles anyhow. So we've got a lot of bootstrapping to do in this area. And how long should you be waiting for changes to be reviewed? So open source certification, there's really no good examples out there that I found. If anyone cares to beg to differ and wants to point me at something, I would welcome it. I like more data is much appreciated. The Linux Foundation has got 4 projects in its portfolio right now. They're looking and working towards trying to get towards safety or security certification. Zephyr, which is a small footprint project I'll talk more about later. Zen, Acorn, and ELISA. And ELISA has just been really launched in the last couple of months. And that's looking more at how do you take Linux into safety critical space. So this is sort of the heart of what I'll be talking about today is the 2 ends of the spectrum, which I'm involved in. The Zephyr and ELISA stories, and then you can sort of see the gamut that we're working towards right now. So for a small footprint RTOS, we pretty much need to make sure that there's key requirements that an RTOS would have. You want to make sure that it's POSIX compliant, there's security in the model, there's safety in the model, there's ISO compliant development, there's friendly interfaces to work with the certification authorities. And when you look at the spectrum of the OSs in that open source RTOS space for the small footprint, these are the candidates that I know about. Okay. And when you talk about the ones that actually have a public path to try to aim for that security goal, or the safety goal here, the ones that most people know about are FreeRTOS, which has become Amazon FreeRTOS. And if you want to go after safety, you have to go through a proprietary story. Zephyr is one of the few right now that is talking about its LTS going to an auditable version of it and transforming the code base that way. The others may have them. I just don't know about them. And if someone wants to educate me, again, happy to update my slides. Now, when I talked about LTS and auditable, what I'm talking about here is the development is what we've been doing up until April of this year with Zephyr. And we finally got the interfaces in a good enough shape that we basically cut our long-term support version, or LTS version. This is very much like what the Linux kernel is doing. We're trying to use some of that models to stabilize and set of that and go into auditable. This is part of restricting the scope, figuring out exactly what we're going to do, and then try to get it into more of that traditional flow. One of the key things here is, independent of which certification you're going after, is that we really need to make sure we have the base code at a high quality level. It has to be a foundation for everything, and that means getting rid of the bugs and not letting them come in the first place. And so it should be a goal of any project. I think the Linux kernel has a high quality standard, as does Zephyr. We're working towards it, and then it's a question of how do we improve it and demonstrate it. The other sort of strategy we're following with this one is building up from the guidelines that are familiar to the certification authorities. We've got this clash between cultures going on, and there are certain things that people agree on and the certification authority, and that we have ability to run as automation tools. And so MISRA C is probably one of the standards we're going to follow on this project, and it is challenged there, though. Specifically, it is controversial. It does refer to proprietary standards, and there is proprietary tooling required. There's no open source options right now that I'm aware of. Again, input's welcome. And our approaches to it, again, from a pragmatic perspective, are being very public about documenting our deviations and limiting what we're actually first working towards to a well-defined scope. and basically building up for developer and contributor buy-in into this, as well as having the contribution guidelines public. So, but there are things that are going to cause ripples and discussions and cause some problems. So that's what we're trying to work our way towards. So more about Zephyr. I think from the audience, everyone here in the audience knows Zephyr, so I won't go too much into it. Hands up quickly if anyone wants me to talk about Zephyr. Okay. All right. So I've just shown you the code repositories. This is how we structured it. This code project, the whole project basically launched with this diagram. And this diagram was around in 2015, and we've been pretty much executing to it since then. So we didn't start Zephyr until we had it figured out how we could eventually go down long-term after these types of stories. And part of it was that rate of change and controlling the rate of change. This story won't work for Linux. I'll just tell you that right now. That's a punchline. But it is viable for Zephyr to start working in this direction. Zephyr's architecture is very modular. And as a result of it being very modular, we can focus on specific areas at specific times. And so what we're going to be doing here is we are going to be going after an auditable scope. We have the things in parts in orange have been identified, and we have people ready to work on them for going after this first version, and that's basically doing the documentation, requirements traceability, and the things that the V model is calling for. And we're trying to build this into the code base as much as possible so we can get the regressions going there. And if there's other, and like I say, once we start with that, as other people want to add in, we'll have a framework and a precedence to build from. So we will eventually go to more complex stacks and more complex ecosystems, but we're starting with the pieces that we have people committed to working on, and then building ourselves out from there. And of course, Zephyr has a variety of use cases it's working on today, from the single core MCU all the way to a hypervisor guest supported on OpenAMP. And obviously, the requirements and complexity are going to grow with these use cases. So this is why it's important to start with well-defined starting points and then go from there. The long-term support for Zephyr was that version, and it is like the Linux kernel's one. It's product focused, it's got security updates, and it's compatible with new hardware, and it's more tested. We're not going to be putting new features in there. It's not going to be cutting edge, but it is going to be a basis for people to build products off of. And so we've been working on the security for it for a couple years now. And we have a security working group that meets bi-weekly. We have our security reporting practices publicly documented for the project. Zephyr is one of the few open source projects that's a CNA right now. And so we have researchers reaching out to us with vulnerabilities, and we are working and addressing them in the security group and reaching out to the right maintainers to get them addressed, and then publicly disclosing them with our releases. So we are taking it very seriously, and we are publicly documenting things by the best practices badge. We're one of the few gold badges out there. There's about 2,000 plus projects that have started working through the best practices project on the Linux Foundation, and there's 3 right now up there that are gold, one of which is Zephyr, and we beat Linux to it, so we were sort of proud of that. The auditable code base, which is that third bucket, you know, the subsequent target was decided by the governing board to be 61508. We'll be keeping the code bases in sync, and the more rigorous processes will be applied into that subset. And we pretty much are going to be having the safety working group and the security working group working together with the TSC. There'll be architects from both of those other 2 working groups in the TSC and helping to make sure that the whole project defines. And there's a feedback loop associated with any changes that are coming into the project as we transform. So what we're doing with the roadmap here is we are continuing on, and the MISRA C compliance is being worked on right now. And then we have some additional features on power management and Bluetooth split layers and things that are coming down the pipe. But then towards the end of the year, we'll probably be looking at getting the next gen Bluetooth technologies in and more of the quality standards being formally published that results from that, and having that code base there. And then into 2021, we'll be going after the formal certifications. And it's part of a reference system, so it's defining the reference system and then pushing it through. We actually have the one member that's looking at trying to do an accelerated path. So you may see something showing up towards the end of this year, before 2020. And we'll see if we get there. So that's kind of a few minutes on how Zephyr's going after this. On the other end of the scale, we have this larger footprint, which is ELISA, which stands for Enabling Linux and Safety Critical Applications. And one of the key insights there is you really need to understand if your system and how Linux is going to be used in the system. And so you have to understand the context and use of Linux, because the same thing we'll be doing in Zephyr won't be applicable necessarily here. So for Linux, we're doing a safety by process argumentation. And what we're using is the fact that there's been a process in place and publicly documented, publicly working for Linux for over 27 years. The process quality is there, and the process improvement quality exists. So there's ways that are publicly documented we can improve our processes with Linux. And we also have a lot of evidence out there that can pretty much identify that it's probably capable of being a safety integrity level 2 or SIL 2 for those who know 26.26.2 for selected parts. And so there's a lot of work that was done by the SIL 2 Linux MP project that was run by OSADL. And we're building off of some of that argumentation, then taking it in some different directions as well. So the key for safety critical Linux and mainline Linux is really going to be the way you use it. The key here is it's mainline Linux. It's no patches being carried out to the outside. That is what's going to be at the heart of this thing. So upstream first is going to take a bigger and bigger priority here, because that's your way of basically eventually building up the argumentation that you can be used in a safety critical space. You're not carrying patches to the side. And so key for this is understanding your system and understanding what parts of Linux you're using in your system. And when you do that, you start to be able to put this argumentation together. So making the Linux-based system safe is going to be a function of the processes and methods being used. And what are the qualities of a complex software system, and what are the qualities of the Linux kernel you're drawing off of? And these sorts of topics are not commonly talked about in developer circles, and so education is one of the things that we really need to be focusing on in this ecosystem. So you'll probably be hearing a lot of talk about safety in the next couple of years as part of trying to get this educational outreach about what's important to actually pay attention to here. So as we try to close this cultural gap, the industry is going to be needing these. There's a clear need. People are caring about it. People are wanting to try to get together to solve it. No one has a good idea how to do it right now. But the functionality and features that are out there right now in open source are too enticing for people. And it's too slow to develop other ways. So we're going to be using this basis about managing the risk in the product development cycle and making sure that we understand more and more about details about the system that's being used in the kernel and how they are interacting. And then, quite frankly, understanding the traceability, understanding what happens when you do a security update, understand, okay, if you've done your analysis and a security update happens, do you have to redo your analysis or not, or can it apply? These are the sorts of questions we're going to be tackling. So I think some more tooling is going to be needed that we have today. And that is kind of how we're working towards it. So we don't have a solution today, but we have a paths and ideas for closing this goal. ELISA got launched to share the development and effort on this part of the things. There's enough people that seem to buy into the thinking that they can't solve it on their own. They want to get together with other smart people and try to get these things figured out. And then, quite frankly, we've got the certification authorities on the other side who are sort of sitting there going, oh my God, it's coming at us. How do we do this? So we've got people from the certification authority side as well as the company side making products coming together and starting to have discussions. And we've also are starting to have some discussions with some of the regulatory authorities as well, because they also see that things need to change and they just don't quite know how. So figuring out how we can get Linux and simple things like Zephyr engaged is going to be the challenge for the next year or two. And how we actually can gather evidence in a standardized fashion and how we can actually do the better analysis. We've got tracing tools in the kernel right now. How can we actually make sure we actually have a better feel for which interfaces are being called, on a system, and then what are the potential dependencies beyond the kernel that are being pulled in, and then training materials needed here. So we have a well-defined governance on this project, and we are focusing on building it up as a community right now. Rather than top-down, we're trying to actually do a grassroots bottom-up and try to get the right people into the rooms and the conversations. And we're going to need to eventually put in together some education. And so this project is going to be focusing on that and getting the experts, as they figure things out, to be documenting them. And then go from there. And so when we are successful at the end of this all, we should hopefully have processes for selecting kernel features and tools, as well as previous process assessments to reference. We should be able to show things are feasible with various reference systems, so we can make the proof point to people that it's there, it's possible, it's doable. And then we also probably have a lot of working with the integrators who are actually making systems and making sure they're doing the right things, thinking about the right questions as they go forward. And, you know, part of the open source methodology is fail fast, fail quickly, etc. But how does this work with a large, long-term industrial grade product lifetimes that are 20 years, which is where a lot of these safety things are running. So the AGL group, as well as the civil infrastructure group, is also both quite interested in this, and there's some cross-pollination between the teams. And obviously the kernel community is interested in how to make this effective. So getting reference systems with reference hardware is certainly one of the goals we're trying to get here. And as a result, we've got a mission statement. Here's our mission statement, which is to get these elements, processes, and tools that can be incorporated into making the systems amenable to the safety certification. So try to do the heavy lifting as a group so that people are just doing the deltas on top. The goals are pretty much as I've sort of talked about already. It's having those elements. It's having a reference Linux system. And that companies are feeling confident about incorporating the output, as well as the open source community, the safety community, the regulation authorities, standards bodies, and system developers all accept the project. So it's a bit of a quest to change the ecosystem here. And so companies welcome. The project deliverables are related obviously to the goals, and we would like to obviously get the safety community to actually start engaging with us in the discussion and in the definition, so that when they see this stuff put in front of them, they're in good shape. We've actually gotten some really good participation from TUSUD at the first workshop, and Underwriters Limited will probably be at the second as well. So we're getting some of the certification authorities coming in because they have the same problem. They're just on the other side of it. And it's a common recognition that we have to figure out this together. So one of the things always that's important is understanding what ELISA will not be. We will not make your system safe, where your system is any arbitrary system. We're not going to be ensuring that you know how to apply the processes and methods. You're going to have to educate yourself and engineers, but we will probably give you paths and training. And we're not going to create one kernel that will rule them all. It's we're trying to figure out how anyone can take a relevant upstream kernel and make the argumentation appropriately, because one kernel to rule them all has been shown to be problematic over time. So it's better to actually try to figure out how we can have the process so you can pull the pieces together to prove something out. And we won't relieve you of your liability because we don't know what your system is. That's, again, at the spot of the people who are making products, and they have the money coming in, and so hopefully they are taking their appropriate care to justify it. But we're trying to give them tools to do it effectively. So we had a first workshop in 2 weeks ago now in Munich for ELISA, and there was 2 systems that sort of got broken into from the people that were interested in the room. Again, we're doing this as a grassroots community thing, and so people who are there who are interested. One of which is taking and extending on the open artificial pancreas system. This is an open source project that's been started by a bunch of type 1 diabetes and various technical friends. And everything on that project is open source, including the boards they're using. They're using Raspberry Pi. They're using Linux on that Raspberry Pi. They've documented the source code. Everything is available without an NDA, and that is key. A lot of the stuff that has liability associated has NDAs associated with it, so we don't have good reference systems to work with up till now. But this one is all there, it's public, and it's an interesting problem to solve. Basically, you're putting the human, today if someone has type 1 diabetes, they use a glucose monitor to monitor their glucose levels, and then potentially have an insulin pump to keep their insulin levels coherent, and they have to do everything manually. And there's alarms, and there's alarm fatigue from dealing with these alarms. And so the idea that came up a couple years ago was basically, oh, hey, we can monitor it, we can adjust it, and then we can, feed the data in. And they were able to do it because there was, quite frankly, a bug in one of the devices, in the glucose monitor. And that was able to broadcast the information so they could consume it and then use it for the analysis. So they've got a lot of motivation to keep things safe because their lives are depending on it. They default back to the default states of the machine, which is the glucose monitor and the insulin pump. But what we're doing right now is doing a bit of an analysis on the Linux and what's being used on Linux, then working towards identifying those key interfaces, and then actually getting the components in the system and understanding what's happening tracing-wise. So we'll either have to work on the tracing technologies, or we'll have to look at the system bomb dependencies, some of these things to really understand what's actually being used in this type of system. And then taking that next level of analysis down, we're hoping to put these people, engage with this group, and since hopefully this will be useful information for them as well. So here's an example that we've got a bunch of people from the grassroots level that are willing to start working on. Now, that was 5 of us. The rest of the 25 were all interested in the autonomous driving problem. And so they'll be building on the Sil2 Linux MP work, and they're trying to figure out a way of breaking this problem down to something that's bite-sized so they can tackle it from that side. So I guess in summary, we can exist, we believe we can exist with the functional safety space. I think one of the things that's clear is we always have to be focusing on project quality, software quality, and keeping the bugs out as much as possible. And then we have to be focusing on how we're going to manage the developers and the certification authority expectations going forward. And part of that's going to be, in some cases, working within a well-defined scope and focus on the interfaces that matter to the system. And then understand realistically what system, you want to be using. And get buy-in from people early that the approach you're taking is going to be worth the time at the end of the day. And the certification authorities are usually quite willing to work with people on that type of model of understanding, okay, in fact, they tend to be very happy if you're coming to them and say, this is what we want to do, here's what it is this approach reasonable? Because they'd rather course correct you earlier than later. And so hopefully they'll be, by participating in this group, they'll be helping to course correct us as we're going along on the methodologies as well. And with that, I just have questions. Does anyone have any questions about this? Go for it, Andy.
So one of the issues is that a lot of the specs, etc., are behind closed doors, etc.
Yeah.
Is there any intention or desire to write an open spec?
Yeah, one of the things we're talking about with the ELISA side is effectively doing an open interpretation of the specification. So we'll be taking the interpretation, the specification, and putting an open source, an open document about it as to how to interpret it for some of the standards. And in some cases, we may start, as we get further down this path, there may be people who we can collaborate with on actually saying what really matters and putting that into a spec form, but that's not an initial first goal because we don't know what we don't know as a group right now in some ways. And they've got the full, like I say, there's a lot of entrenched interests in this space. And so the open source side is coming into this from a new perspective, and so the data should get interesting from that side. But I don't rule it out as a long-term goal, coming up with something that's open completely, and just basically coming up with the argumentation and say, okay, if you do this, 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 and this, and we'll be doing part of that anyhow, but making that a formal standard is a different type of story. like I say, we're just starting to explore standards with OpenChain right now. Things like that. Does that help? Yeah, okay. Is there another question, or go for it?
I was actually going to ask whether you thought that there seem to be some use cases where the fact that some of these certifications and standards are proprietary doesn't really matter. Like in the Zephyr use case, it's not really don't get me wrong, it's not really a community open source project in the way that the Linux kernel is. And these people clearly want to put it in a product. And so the fact that there is these barriers to getting that certified for them to put it in a product that is safety and security critical, I was sort of like, eh. But then things like the insulin pump example, then that changed my mind. So I no longer wanted to ask the question, but I thought it was an interesting topic to bring up to see how difficult do you think that barrier is? Because I think in some cases it's not.
It really is a barrier in the sense of people don't know what they don't know. It's that type of barrier. So one of the things the Zephyr project did is they actually paid for developers to go through a 3-day orientation about safety at TÜV Süd in Munich in March. And so basically the project made it available to the members to go and have the developers there. So all of a sudden it wasn't just one person who understands safety. There was a couple handfuls to reinforce, there's about 10 people there to be able to reinforce each other. And as you're trying to build a community and shape the direction, having that sort of mutual reinforcement is going to be key for actually making it happen. So these are some things that, like on the Zephyr side, we're doing. And I'm hoping that we'll figure out equivalents on the Linux side as well for that education thing. Because you can go around and give talks about these things, and you can bring experts in to give talks. But if people aren't there to listen and don't understand the relevance to themselves, they don't absorb it as much. And so it's making it so that there's a community and there's people that are seen as leaders to be listened to. And then some of this is going to effectively be a community building exercise, which is interesting to me too as well. Thanks. Okay. Any more questions? Well, thank you very much for your attention and staying around for the end of the day, end of the session. Thank you.